for, I don't know, 30 minutes or whatever, and then you'll have the rest of the time in class to work on whatever is the highest priority thing for you. Sound good?
Oh, when is our feedback due?
So it'll be doing the, this week's homework check will be the last of the problem set and the review packet.
Okay.
So it's possible some people will be taking the test before the packet is due just because of when the homework check's live. Not the case for you guys, but some of the classes that is the case. Okay, so we'll start just with a little bit of talking about the test format. Everything I'm showing you right now is in the content library, so you don't need to write this down if you don't want to. You're welcome to do that, obviously, if you want, but it's there in the content library. So the first two questions on the test, I'm going to ask you to find the domain of some function and show some work. So like the algebraic steps as to like how you got that specific domain. The next two questions will be proving things are odd, even, or neither. The next two questions will just be determining whether something's a function or not. The next four questions will be like I'll give you some functions and ask you to like perform the indicated operation. So like addition, subtraction, multiplication, division, composition, like do something like f times g or whatever. The next two questions will ask you to write the inverse in the same form as the function. So maybe the function is a mapping diagram. When you write your inverse would be a mapping diagram. If your function was an equation, your inverse should be an equation. If your function was a graph, your inverse should be a graph, etc. One question where I ask you to verify that two functions are inverses. So the way you do that is you do f of g and then g of f and show that they both compositions give you x. One question where I give you a parent function and ask you to describe the transformation on how you get to some resultant function. One question where I give you a parent function and some transformations and ask you for the new resultant function after those transformations. And then one question where I give you the parent function as a graph and I ask you to draw the graph for the resultant function and describe the transformation. So that's the test. It's those kind of 16-ish questions. I don't think there's anything that has multiple parts on this one, so I think it's just these 16. Any clarification on what I mean by any of that or whatever before we dive into specific individual things? Arya?
For the 5 and 6, is it like put it down?
Sure. Yep. Okay. On to specific things. So again, if you have a question about anything, problem set, review, something more general even than that, we'll just kind of knock out some questions for the next 30 or 45 minutes, kind of in that capping at that kind of length, but if it's less than that, that's okay too. And we'll just kind of go until you guys run out of questions or we run out of time. Sound good? Tommy, we'll start with you.
It might be a dumb question, but what's perform the operation?
So things like, so if you're looking at the review, stuff like these, so section 7, question 6. So just stuff like that would be like perform the operation things. You're good with that?
Yeah.
Okay. Dominic?
Is there an easy way, if you look at a graph, to figure out if it's one-to-one?
Horizontal line test is the easy way. So if it intersects any horizontal line more than once, it's not one-to-one. Blake?
If it's one-to-one, does that mean that its inverse is not a function? Or it is a function?
Yeah, for our purposes, yes. Technically, it also needs to be onto, but the onto-ness will just be, we're just going to take that as if it's something that's written as a whatever, like an equation, we're going to call it onto.
I have it up.
So it's going to be okay. Amanda,
Can you do it?
from the homework?
Yeah.
Sure. So 55. Okay. So here we're just looking to verify that the pair of functions are inverses. So we have to do f of g of x, and then we also have to do g of f of x, and both of those should give us x. Amanda, if it's okay with you, we'll probably just do one of the two directions because the other one's kind of the same thing. Or close enough to it that it shouldn't be. If you can do one, you should be able to do the other. So what I'm going to do is I'm going to take my g of x, and we're going to plug it into f of x. Oops. So kind of everywhere in f where there's an x, I'm going to replace it with negative x minus 5 over x minus 1. So far, so good, Amanda? Okay. Now to simplify from here, I have a couple of options. So I could make a common denominator in the numerator and add the two fractions, and make a common denominator in the denominator, add the two fractions. And once I have a single fraction in both, multiply by the reciprocal and kind of just work on canceling things down. That's one way. That's kind of the obvious way to do it. I don't like to do it that way because it's kind of a lot of work. What I would do instead is I noticed that the denominator in each of the little fractions is the same. So what I would do is just multiply the top and bottom by x minus 1. It's okay to do that because really what we're multiplying by is just 1, right? If I have the same thing in the numerator and denominator, which doesn't do anything. So when I do that, I have to distribute to both terms in the numerator and both terms in the denominator. When I multiply x minus 1 to the fraction, the x minus 1 cancels with the x minus 1 in the denominator. So all I'm left with is the numerator. And then it distributes to the other piece. And I do the same thing in the denominator. So the x minus 1 in the numerator cancels with the x minus 1 in the denominator. And then still have to distribute it to the 1. And that's pretty great because I'm already down to no fractions inside of my fractions, right? Instead of that taking like 3 or 4 steps, I knocked it out in 1, which is pretty rad. So from here, all I'm going to do is distribute and combine my like terms and then reduce, and I should be good. So I have a plus 5 and a minus 5 in the numerator that cancel out, and a plus x and a minus x in the denominator. And when I combine my like terms, that's just negative 6x over 6, which just reduces down to x. And obviously, doing the other composition, things are going to work almost the exact same way, right? There'll be obviously, so symbols might be different along the way, but it's going to like the same steps. Does that feel okay? Yeah, and that's the trick, right? To make life easier is just doing that. Did you try to do it the other way? Yeah. Making comment, it gets messy, right? Yeah. More stuff to keep track of. It gets worse before it gets better. This was nice because it just gets easier. Luke. Sure. 56, okay. So same directions. So again, we'll do f of g of x. In this case, our g of x is the natural log of x plus 5 over 3 minus 1. So when I plug that in, I'm going to plug that into the x in f of x. 3e, and then instead of my x, I'll have the natural log of x plus 5 over 3 minus 1. And then I have that plus 1. And then down here out of the exponent, I still have the minus 5. Good with the composition that we did there? I guess there's probably another parenthesis there. So first thing I'll do is I can get rid of the minus 1 and plus 1. And then exponent base e and log base e can cancel. And then the times 3 and divides by 3 can cancel. And the plus 5 and minus 5 can cancel. And there's that. Going the reverse direction is pretty similar. Are you good with skipping that? So the big key here, the thing that, like maybe wasn't obvious to remember, is that relationship between exponent bases and logarithms. And the natural log is log base e. So again, that was something you would have talked about last year, but if you're like, I didn't really remember that, that's not the end of the world. Not being expected to be masters of that anymore, but should be familiar with, like when we remind you, it's like, oh yeah, okay. All right. So if the function itself is 1-to-1, the inverse should be 1-to-1, or should be a function. So you can basically just look at the graph, and if it passes a horizontal line test, then the inverse should be a function. It's kind of the easiest way to do something like that. And really, for most of the problems where I asked you if the inverse would be a function, that would be the easiest way to go about doing it. Does that feel good? Okay. Blake.
Could you find the inverse relation for number 50, please?
50. Okie dokie. Negative x 7 minus 23 over x plus 3. Okay, so this is one where I have x's in two different locations, right? I have x's in the numerator, x's in the denominator. I think the first thing I would want to do is to get rid of the fraction, so I can just think about this like as a cross multiplication thing. Or multiply both sides by x plus 3. That's fine to think about it that way also. Then I'll distribute the y through. And then I'm going to move the stuff with x's onto one side and the stuff without x's to the other. So I subtracted xy, or added, subtracted xy from both sides and then added 23 to both sides. So on the left-hand side, I have a greatest common factor of x, so I can factor that x out, which is nice because now I get rid of the x's being in two different locations. Now I just have one x. So from there, I'll divide both sides by negative 7 minus y. And then I just switch my x and y variable names. And I'm done. And you could do some monkeying around with negatives to get an equivalent expression if you wanted to, but this is fine. right? Like you can pull the -1 out front and write the denominator with all plus signs. But like whatever, you know. If we're arguing about a negative sign, I'm not gonna, obviously that's not a deduction if your answer would differ from the one that I did. You know what I mean? Especially on something like this where it's just a matter of preference where you want that negative at. Yeah. Is that cool?
Perfect. Thank you.
Yeah, no problem. Rob?
Are discontinuities on the test?
No, we didn't mention that in the list of things to worry about. Anise? 52, you say?
Yeah.
So like there's like a whole bunch of parts to 52. Do you need all of them done or some of them or?
Just like finding the
Okay, so just part E? Okay.
and yeah,
And D? Okay, what was your answer for C?
I like did that because so that's a function.
So, well, it'll be, so D you're looking at whether, or part C you're looking at whether the original thing is 1-to-1. It would be, because when you graphed it, it should look something like that, because it passed the horizontal line test. Because it's 1-to-1, its inverse would be a function. So that's all you need to do for part D. It just, whatever you answer for part C is tells you the answer for part D. Cool. So here, we'll start by trying to get the x by itself. So I'll subtract 8 from both sides. Next thing I got to do is get that log out of there. So what cancels a logarithm? An exponent base. Which exponent base would I want to use for this problem? I want the base that matches the base on my logarithm. Notice there's no subscript on this logarithm, which tells me the base is 10. So this is the common log, is what we call this. So on the left side, I'll have 10 to the y minus 8. And on the right side, I'll have 10 to the log x minus 1. And exponent base 10 and log base 10 cancel. And then I just add the 1 over to both sides and switch the x's and y's. Is that okay? Did you see it or no? Yeah, it's okay. There won't be any on the test, don't worry. Just provides us a good opportunity to talk about them a little more because I know that they're always a shaky subject coming from Algebra 2.
Yeah.
So it gives us a little bit of chance to review again before we do it in earnest second semester. Sure. With that charger and that cord, you can probably pull it close enough that you don't even have to like change your location. Yeah, that guy's pretty long. Well, the charger, well, you have that extension cord there if you want. You can probably get it all the way to between the length on that thing and that thing. You might be able to get it all the way to your desk without having to move all your junk. You can do that if you want. It's not a big deal. I just figured, you know, if you don't have to get up and move it, it's just one less thing. But whatever you want to do is cool with me. No biggie. Who else? Do we have others? Yeah, Paul.
Did you do 61?
61? Sure. Okay. So it says to describe in words how the graph of y equals the square root of x can be transformed into the given.
Oh, wait, sorry, I didn't mean 61.
Okay,
My bad.
that's okay.
65.
65?
Yeah.
Sure. Oh, the graph?
Yeah.
Okay. No problem. So what I'm going to be using for this, I'm going to use a couple of different facts. So I'm going to use the general transformation for a function. So in our case, f of x is this bracket x function, which is just like a made-up thing. So I'm just going to rewrite this using that made-up function. So if I look at 65, I see that I have an A. Good with that. There's no coefficient on the x, so the c is definitely 1. My h is 4. And then my k is -1. We good there? Okay. Once I have that, the second thing I'm going to use is the way to transform a point from a parent function to a resultant function is using this map. So in our case, xy is going to go to x plus 4, 1/2 y minus 1. And then I'm just going to use a few of the key points from my graph and transform them and then just kind of connect some dots, okay? So I have this one, -2, 0. I have this one, which is 1, 2. And I have this one, which is 2, 0. So my first point is going to be 2, -1. The second one would be 5, 0. And the second one would be 6, -1. So I'll just go back in and plot these. Well, they're not really on the chart anymore, huh? I'll just kind of make it up. It's probably about where 5 is. So it looks something like that. Is that okay, Paul?
Yeah.
So again, for your test or whatever, like these two things will likely be quite useful for you in order how to peel off the values for A, C, H, and K, and then how to transform your points. Dominic?
Is there a difference between C and B?
It's just like a letter.
Okay.
Yeah, it just
last year. That's what
yeah. I think that depending on who you had, people call it C or B. It's just a label.
Okay.
So you call it taco if you wanted to. 1 over taco, whatever. Anise?
How many times for the
Or if they're not, you'd have like a grid on there to where you can like reasonably ascertain the points that you'd need. Like the points weren't given on this. I just pulled them from the grid. You know what I mean?
I was just wondering if you wanted to say this.
I wouldn't give you something that complicated right now. I mean, I can give you something reasonably complicated, but like, yeah, it wouldn't. The coordinates would be much kinder than what the coordinates you'd get off of a sine or cosine graph. Right now. Eventually we'll graph those things and do transformations on them, but we haven't even talked about what the unit circle is yet, so the coordinates would probably not make a lot of sense to most of us. All right. The range for 51?
Yeah.
Okay. Oh, okay. So the domain we found was all real numbers, right? 51b. So, and I notice that this is increasing the whole time if I were to look at the graph of this, right? Since it's exponential, it's going to look like that. So I know that the range then is going to be f of negative infinity to f of positive infinity. Okay with that? When I do f of negative infinity, I have 7 times 2 to the negative infinity minus 3 minus 5. So this is really 2 to the negative infinity, right? Which is the same thing as like 1 over 2 to the infinity. Remember, a negative exponent means a reciprocal. So if I have 1 over an absurdly large number, that is basically just 0. So 7 times 0 minus 5 is just negative 5. And then if I do f of positive infinity, now we have 2 to the infinity, so that's just infinity still, right? Or you could have, since I don't think I asked it for necessarily algebraically, you could have just noticed this was looked at the graph, the horizontal asymptote is there at 5, or negative 5, excuse me, and it's going up.
So, what is it?
You can do it that way, but the directions for this don't ask you to find the range or domain a specific way. So you could reasonably just look at the graph and like use your common sense. Like, would not be wrong to do that. Now I did it this way because I assumed that's what you were having a question about, was like, how do I do it this way? But you could certainly look at the picture and go, okay, that looks like negative 5 to positive infinity to me. And you would not be wrong. Is that okay?
Yeah.
Okay. And you can certainly, if you look at the picture and you're like, ooh, do I have a bracket or a parenthesis? You can try just plugging negative 5 in for y and solving. If you try to do that, it's going to be impossible because you'll be taking the log of 0 at some point, which is undefined, which would tell you that negative 5 is not a part of the graph, so you can use a parenthesis instead of a bracket. Is that okay?
Yeah.
Okay. You guys are really beating up this little section here of, 40 through 56 or whatever. I've crammed in a lot of stuff here. Others, happy to do more. Again, we can talk about the review or the questions or whatever you feel like. Tegan?
I'm kind of confused on how to tell if something, like I know how to tell if something is odd or even, but how do you tell if
It's neither odd or even.
okay.
So it's just by elimination. Like if it's not odd and it's not even, then it has to be neither.
Okay.
Is that okay?
Yeah.
I mean, it was kind of a, like a silly answer, but, like try to make it as simple as possible. You know what I mean?
Yeah.
So we'll stop here. If you guys